Here we are going to attempt a variation of an ancient and famous problem, that of trisecting an angle. Of course, modern mathematics have shown that it is an impossible thing to do if you are merely using a compass and a straight edge. So we'll have to use something else, say a mechanism in this case. And then again we are going to invert this problem upside down by not trisecting the angle, not dividing by 3, but by triplicating it, multiplying it by 3. And therein lies the key, trisecting an angle as well. So let us start with the basic geometry that is involved here. Here is the angle given to us, say AOB, and the angle at O we'll be trying to triplicate. For that we are going to take a point C on arm OA so that OB and BC are equal, and that forms an isosceles triangle OBC as shown, and of course the angles therefore opposite these equal sides will also be equal. So these two angles are equal. Now let us think of the angle external to this triangle here. So this particular angle, which will be the sum of these two, and since they are equal it will be twice each of them. Then we are going to do one more construction. So one more line which is equal to OB or BC, and this time we have taken the point on the other arm OB here. This again forms an isosceles triangle. So these two sides being equal, the angles opposite to them will also be equal. So this is the triangle, and this angle here is going to be equal to that angle. Now let us consider the union of these two triangles. So instead of considering these two small triangles, we are going to consider this large one which is made up of both of them, and then we'll take the external angle to it. That angle of course will be the sum of the angle here and the angle here. If we take this as 1 unit, then this will be 2 units, and therefore the external angle will be the sum of them, that is 3 units. So in short, this angle is 3 times the angle over here. So if we start with this one, this is the 1/3 of it. So by doing the triplication of a triangle, we have also found how to divide by 3. Now let us make a mechanism out of it. Here is a schematic mechanism that we have put together from our basic geometry. So you can see this AOD, that is our basic angle, AOD. Then these lines BC and this point D that we had constructed, BC and D, are also here. Now let us see how this works. So we'll move this mechanism. Right now the angle you can see is 75 degrees. Let's go to the other end where we have fixed a protractor, and you can see it is 25. So at least in the configuration shown, it is really trisecting this angle ACD. Let's move it and see if it works for other angles as well. So I'm going to move it to say 45 degrees here. So let's confirm it is 45 degrees at this end, and it is 15 degrees as required, the 1/3 of it at the other end. We can try some other angles as well. Let's say 60 degrees here, and indeed we are getting 20 degrees. So this is a mechanism that will help us trisect an angle. Now let us figure out what kind of joints and links we need. As you can see, this point D here is sliding on the green link, so we need some kind of slider at point D. Then this protractor also, the point O, is sliding on the horizontal line, so we need another slider over here at point O, which will be guided in a horizontal link, say AO or ACO. So let's make a mechanism out of it. So here is that mechanism. We have added this slider at point O, we have added another slider at point D here, and at B we are having a hinge, that is this point, which will not be moving on the link, but it will be pretty fixed to that link. So this kind of mechanism can also be used for trisecting the angle. Now before we close, something of a personal interest to me, a history that goes back to my student days when I was studying kinematics from Professor Khanderia, and he had given us an assignment to actually make some physical mechanisms, and one of my friends had selected this one from a Russian book, Artibolevsky, And I distinctly remember telling my friend that don't try to present this mechanism as something that triplicates an angle, but name it as a trisection of angle mechanism, and there would immediately be an interest and excitement in the class. Coincidentally, just a couple of weeks back, Professor Khanderia found this mechanism in some of his old papers, and he emailed it to me. That brought back all those old memories. So not only this mechanism, but essentially all the kinematics that you see on this channel is basically a gift of Professor Khanderia to me. He still remains a friend, philosopher, and guide to me and my family. So I dedicate this and all the kinematic videos on this channel to him. So thank you, Professor Khanderia. It has been an honor learning it from you.